Here we're going to look at some parametric equations. Parametric equations have a third parameter, or a parameter that has a function of x and y. For this to work, we're going to need to play with our chain rule. dy dx equals and we're going to get rid of the du and replace it with a dt, because there's our t. Anyway, we need to play a little bit with this, but let's just get into it. Okay, so if x equals t squared, then surely we can say dx dt is 2t. If y equals, I don't know why I wrote that out again, dy dt is 2 minus 4t cubed. Can you see our dy dt? So we can say dy dx is going to be dy dt times dt dx. Right. We have a dx dt, but this is flipped around the wrong way. So we're going to multiply both sides by dt, divide both sides by dx, and then get the 2t to the other side. All of a sudden we've got a dt dx. So we can just go dy dx is, can you see the 2's are going to cancel? So we've actually got dy dx in terms of the parameter t, but it's definitely a gradient function of dy dx. How much fun was that? So much fun, let's do it again. So dx dt. Here that a is just going to be a constant, like a number. So we've got 2a, and dy dt is just going to be 2a. And we know dy dx will be so we want to flip this around. We want to get it as dt dx is 1 on. So it's simple substitution now. So it's 2a on 2at. So there's our dy dx. There you go. Do we have any more to play with? Oh, yes. Okay, trig's a little different. We love trig. No, correct. No one loves trig. We can't do the whole flipperoonie because that t is going to be caught inside that trig function. So we can't manipulate like that. So we need a different solution. And this is where you just need to have done a whole heap of parametric equations beforehand and gone, hey, what if I square that side? And I square the next one. And that's equation 1, that's equation 2. And I add x squared plus y squared. That's going to be 16 outside of sine squared t plus cos squared t, which is, oh my gosh, it's a circle. I'm sure you saw that. And now we've just got to determine dy dx. So here I'm not going to have any of that stuffing around with the t's. I'm just going to differentiate 2x plus 2y 0. We've done that a few times now, haven't we? Okay, so there's our trig. Yum! This is where you panic. sec t and tan t. Oh my gosh, no, it's not. Time to panic. We are going to just look at our formula sheet. And our formula sheet, pretty sure it's sec squared minus tan squared equals 1. But when we square this 3 and the 4, remember we can't factor it out, we have a problem. So we're actually going to get that 3 to the other side and then square it. So that'll be y squared on 16. And then we're going to subtract 1, 2, 1 minus 2, x squared on 9 minus... Hey, surely you can remember us doing that in another video. We're just going to implicitly differentiate that. But since we've done it before, no need to do it. But you can see if we know our parametric equations and we're comfortable with our trig, these things are not going to pose a problem. Clearly you need to be able to do that, but if you're struggling with that, go back to the other video where I do that exact question. Go have some fun in some parametric equations.